You remember the insult, not the compliment that came before it, not the 3 compliments that came after it, just the insult. One sentence from one person on one afternoon, and your brain held onto it like it was a survival manual. That's not a flaw, that's architecture. Your brain was never designed to make you happy. It was designed to keep you alive. And in the world your brain evolved to navigate, the things that could hurt you were far more important than the things that could delight you. This is called negativity bias, and it is quietly shaping every memory you carry, every decision you make, and every emotion you feel right now, today, without your permission. In 2001, social psychologist Roy Baumeister and his colleagues published a landmark paper with a title that said it all. Bad is stronger than good. They reviewed decades of research across nearly every domain of human psychology: relationships, learning, emotion, decision-making, first impressions, feedback. In every single category, negative events, negative emotions, and negative information produced a stronger, more lasting, and more immediate impact than their positive equivalents. Not slightly stronger, dramatically stronger. To feel genuinely balanced, to feel okay, you need roughly 5 positive experiences to counteract a single negative one. 5 to 1. That ratio comes from researcher John Gottman's decades of work on marriages and relationships. He observed hundreds of couples in his lab, tracking every interaction, every facial expression, every tone of voice. He found that stable, happy couples maintain at least 5 positive interactions for every negative one. Drop below that ratio, and the relationship begins to unravel. 5 to 1, think about what that means. Your brain isn't just remembering the bad more often. It's weighing each negative experience 5 times heavier than a positive one. But why would evolution build you this way? To answer that, you need to understand the world your brain was built for. For the vast majority of human history, survival was not a given. It was negotiated, every single day, with predators that hunted in the dark, with food supplies that could vanish overnight, with freezing temperatures, infections, and other humans who wanted the same scarce resources. In that environment, missing a threat could kill you in seconds. Missing a reward just meant you were a little hungrier tonight. Your ancestors who noticed the rustling in the grass survived. The ones who stopped to admire the wildflowers got eaten. Over millions of years, this asymmetry sculpted your nervous system at the deepest level. Your brain evolved a fast-track alarm system centered on a tiny, almond-shaped cluster of neurons buried deep in your temporal lobe. It's called the amygdala, and it has one job above all others: detect threats. Fast. Neuroscientist Joseph LeDoux spent decades mapping the amygdala's pathways. What he found was remarkable. When your senses detect something potentially dangerous, a sudden loud noise, a shadow that moves wrong, an unfamiliar face that looks angry, the sensory information reaches your amygdala before it ever reaches the parts of your brain responsible for conscious thought. Your brain reacts before you even know what's happening. LeDoux called this the low road. Raw sensory data, straight to the amygdala, no filtering, no context, no analysis, just a blaring alarm. The high road is slower. It sends the same sensory information up through your cortex, where you actually think about it, evaluate it, weigh the context, and decide whether it's truly dangerous. But by the time the high road finishes its careful analysis, the low road has already triggered a cascade of responses. Your heart is already pounding, your muscles are already tense, cortisol is already flooding your bloodstream, you're already flinching. Speed mattered more than accuracy. That was the deal your ancestors made with evolution. Better to jump at 100 harmless shadows than to hesitate once when the shadow was a predator. And here's where it connects directly to your memory. When your amygdala fires, it doesn't just trigger a physical response. It sends a signal to your hippocampus, the brain's memory center, and essentially tells it, this one matters. Encode this deeply. Do not let this go. The hippocampus obeys. Researchers Larry Cahill and James McGaugh demonstrated this in a series of elegant experiments in the 1990s. They showed participants a series of slides depicting a neutral narrative: a boy walking through town, visiting his father at work. Same images for everyone, same story. But for one group, the researchers added a single emotionally disturbing detail in the middle: an accident, an injury, something that made the stomach clench. A week later, the participants who received the emotional version remembered significantly more. Not just the disturbing detail, the entire surrounding narrative. the contextual memories, the sequence of events before and after the trauma. The amygdala's activation had enhanced the encoding of everything that happened during that emotional window. Negative emotions work like a highlighter in your memory. They don't just mark the painful part, they darken the entire page around it. This is why you remember exactly where you were when you got devastating news. This is why you can replay an embarrassing moment from a decade ago with photographic clarity, but cannot recall what you ate for dinner 3 days ago. This is why a single cutting remark from a teacher in the 5th grade can outweigh years of praise and good grades. Your brain isn't being petty, it's being efficient. At least it's being efficient for a world that no longer exists. Here's the problem. The threats your brain evolved to detect, predators, starvation, hostile strangers with weapons, are almost entirely gone from your daily life. But your amygdala doesn't know that. It doesn't read the calendar. It doesn't know what century you're in. It fires for deadlines. It fires for awkward conversations. It fires for an email with an ambiguous tone. It fires for a text message left on read for 3 hours. It fires for the expression on your boss's face that might mean nothing but could mean everything. Your modern life is saturated with low-stakes situations that your ancient alarm system reads as high-stakes emergencies, and every single one of them gets preferential treatment in your memory. Think about how this plays out in your ordinary day. You give a presentation at work. 19 people nod, smile, and say it was great. One person checks their phone and looks bored. That night lying in bed, staring at the ceiling, who are you thinking about? Not the 19, the one. You post something online, 40 positive comments, one cruel one. Which one do you reread at 2 in the morning? Which one do you carry into the next day like a stone in your pocket? You have a genuinely good day, productive, calm, meaningful, and then someone cuts you off in traffic on the drive home. Suddenly the whole day feels ruined. Not because it was, but because your brain just tagged that last experience with a threat marker, and the threat marker is what your hippocampus prioritizes. Rick Hansen, a clinical neuropsychologist, described this with painful simplicity. Your brain, he said, is like Velcro for negative experiences and Teflon for positive ones. Bad things stick. Good things slide right off. This isn't weakness. This isn't anxiety disorder. This isn't a personality flaw you need to fix. This is the architecture of a system that kept your species alive through 200,000 years of genuine, constant danger. But here's the counterintuitive part. The same mechanism that makes you vulnerable to rumination, anxiety, and obsessive self-criticism is also what makes you capable of learning from your mistakes. Negativity bias isn't just about fear. It's about adaptation. When you fail at something and it stings, really stings, that sting is your brain updating its internal model of the world. It is rewriting your predictions so that next time, you are less likely to make the same error. The pain of a failure is literally your brain's way of saying, remember this, encode this, do not repeat this. Without negativity bias, you would walk into the same traps over and over and over. You'd touch the hot stove again. You'd trust the person who betrayed you again. You'd repeat the same catastrophic mistake and never adjust. Negativity bias is the price of being a learning organism. It is the cost of having a brain that updates itself based on experience. The pain is the update installing. But in the modern world, this system overfires. Constantly, relentlessly, the news cycle is optimized to trigger your amygdala. Social media algorithms are engineered to surface the content that provokes the strongest emotional reaction, and the strongest emotional reaction is almost always negative. Outrage, fear, disgust, moral indignation, anxiety about the future. You are living in an environment that has learned to exploit your brain's deepest evolutionary wiring. And your memory is absorbing all of it, preferentially, silently, without ever asking your permission. So what do you do with this knowledge? The first step is recognition. You are not your brain's alarm system. You are the one who can observe the alarm and decide whether the threat is real. There is a space between the trigger and your reaction, however small, and in that space is your power. Cognitive behavioral therapy, developed by psychiatrist Aaron Beck in the 1960s, is built on exactly this principle. You learn to recognize when your brain is catastrophizing, when it is assigning 5-alarm urgency to a 1-alarm situation, and you learn to challenge the interpretation, not to suppress the emotion, not to pretend everything is fine, but to question whether the story your amygdala is telling you is actually true. The second step is intentional positive encoding. Because your brain will not do this naturally, you have to do it deliberately. When something good happens, and good things happen every single day, even tiny ones, pause, stay with it. Let it sit for 10 or 15 seconds instead of brushing past it. Give your hippocampus the time it needs to catch up. Give the experience room to actually register. It sounds almost absurdly simple, but the neuroscience supports it. The difference between a memory that fades by tomorrow and one that sticks for years is often just a handful of seconds of sustained, undivided attention. Your brain is not broken. It is ancient. It is a survival machine built for a world of real teeth, real cold, and real darkness. The fact that it sometimes misfires in a world of push notifications and passive-aggressive emails doesn't mean it has failed. It means you now have to learn something your ancestors never had to: how to choose what you hold on to. You remember the insult, but now you know why. And knowing why is the first step to deciding what you remember next.